Here we are in West Virginia. Welcome back, everyone. So I am ready for joke of the day because it is the best part of the day. Are you ready? I know you're ready. So why was there thunder and lightning in the lab? Well, because the scientists were brainstorming. All right, let's brainstorm our way into factoring trinomials. We're going to continue looking at factoring trinomials with a leading coefficient that is not a 1. And remember, we said that when you do that, you always, anytime you factor, you always do that common monomial factoring first. You first look and see, is there something common that I can divide out of every single term? And then after you've done that, then you head for that double parentheses. Now, when you head into the double parentheses, as we discussed before, I've got 4 methods in my toolbox that I can show you. And those 4 methods are guess and check, where you just keep guessing and playing with the numbers until you get the right combination. Or we've got our factoring by grouping, and recall factoring by grouping creates a 4 polynomial so that you can pair up each of those 2 terms in the front, 2 terms in the back, creating a common binomial by factoring each of those pairs. And when you create that common binomial, that common parentheses, you can divide out that common parentheses. And then we've got our box method that starts like the factoring by grouping. It creates that 4 polynomial, but then you put those 4 terms within a box. You snake your way around the box. You factor across the rows and factor up the columns, and then your answers are on the outside. And then we've got our slide, divide, and reduce, where the name tells you exactly what to do. And recall I told you that there are other methods that are out there. You can go on YouTube and find other stuff. These are just the 4 that I'm proficient at and can show you. So let's get into this. Now, you may be thinking, no, wait a minute, I've seen a video where you showed me how to do these 4 methods, but what you're going to notice in this video is that we're going to have some extra variables in there. And does the extra variables change the method? And in addition, we're going to see where we actually will divide out something common in the beginning, because we've not seen that yet. So let's take a look at our first example. Once again, always look first to see if there's something common that you can divide out before you do anything else. And here there is not. Now granted, I can divide s's out of here, but not here. I can divide t's out of here, but not here. Notice that I can divide a 4 out of both of these, but not here. So there still is nothing common that I can divide out. So I'm ready to head for that double parentheses. Now remember, with the old guess and check, I'm just simply going to play around with these numbers until I get that right combination. And so what happens in the old guess and check is I'm going to look at this back sign. This is telling me that it's a positive. This is telling me that they're both not positive, but they're the same. This is telling me they're both minuses. So now what I'm going to do is I'm going to split this into the front slots. Oh, there's going to be a lot of guesswork happening here, because that 15 splits up as a 15 and a 1, or it splits up as a 5 and a 3. But what I do know is that that s squared splits up as an s and an s. Now this 4t squared, the t definitely splits up, and let me spread this out a little bit better. Definitely splits up as a t and a t. However, the 4 splits up as a 4 and a 1, or a 2 and a 2. This is where I'm saying there's going to be a lot of guesswork involved in this. So let's start off with that 15 and that 1, and let's see what happens. So I'll put a 15 here. Whoops, get that, there we go. And a 1 here. And let's try the 4 and the 1. So I'm going to check my outsides and my insides. Out here I'm going to get a minus 15 st. In here I'm getting a minus 4 st, which gives me a minus 19 st. Definitely not what I wanted, because I wanted a minus 16 st. So before I toss them all out, I'm going to switch them up a little bit, and let's call this the 1 and let's call this the 15. Now remember, don't switch both these and these, because that'll totally mess your combinations up. Now I get a negative 1 st, and in the middle here I get a negative 60 st. That gives me a negative 61, definitely not what I want there. So now I'm ready to throw out one set. Don't throw out both sets, only throw out one set. So perhaps I'll throw out the 15 and the 1, keep the 4 and the 1, let's try a 5 and a 3. Now on the outside I get a negative 5 st, and in the inside I get a negative 12 st. That gives me a negative 17st. Still not quite what I want, but before I throw it out, I'm going to switch it up. So let's switch this as the 3, and let's switch this as the 5. Now on the outside, I get a negative 3st, and on the inside, I get a negative 20st. That gives me a negative 23st. Yet again, not quite what I want. So I'm ready to throw out, well, wait, before I threw, oh, I messed up. Before I threw out that 15 and the 1, I should have tried the 2 and the 2. Or what I can say is, I'm exhausting every option with my 4 and the 1. I've tried the 4 and the 1 with the 15 and the 1. I've tried the 4 and the 1 with the 5 and the 3. 4 and 1 is definitely not the right combination here. So let's give a shot with the 2 and the 2. And let's start out with that 15 and that 1. So now on the outside, I'm going to get a negative 30st, and on the inside a negative 2st, and that gives me a negative 32st. Definitely not what I want. Now I should switch things up, but if this is a 2 and a 2, switching things up is not going to matter. I'll just get back to the same numbers. So I know 15 and 1 is not the right choice. Let's try that 5 and that 3. Now on the outside I get a negative 10st, on the inside a negative 6st. That gives me a negative 16. Aha, there it is. That's what I wanted. So my answer is a 5st minus 2t, or sorry, 5s minus 2t, and a 3s minus 2t. So for those of you who were completely exhausted by that guess and check, let's try factoring by grouping. Now remember, what factoring by grouping does is it creates a 4 polynomial. So I'm taking this middle term and I'm splitting it up into 2 terms. So I'll keep that 15s squared, and I'll keep my 4t squared, but now I want to figure out how to split this up. So the way I'll go about it is I'll multiply that 15 times 4, and when I do 15 times 4, I get a 60. So that means I want a pair of numbers that will multiply for 60, but they will add up to be the 16 that's in the middle. So that's going to be a 10 and a 6. 10 and 6 multiply for 60, they combine for 16. So I'll keep my 15s squared, split this up as a minus 10st and a minus 6st. And I'll keep my 4t squared in the back. So I've turned this trinomial into a 4 polynomial so that I can pair up these and pair up these. Now that I've got these paired, I'm going to divide out what's common. And remember, my goal is I want to make a common parentheses that I can divide out. So as I look at these, I'm going to divide out a 5s. When I divide a 5s out of here, I'm left with a 3s. When I divide a 5s out of here, I'm left with a negative 2t. And I'm going to do the same thing right here. Both of them are divisible by 2 and a t. Now remember, I want these parentheses to be the same. So perhaps I should divide that negative 2 out, so that here I get a 3s, and then when I divide this by a negative 2t, I get a negative 2t. So even though it feels kind of weird, here's those funky looking terms. One here and one here. Each of them has that common parentheses of 3s minus 2t. So I'm going to divide that 3s minus 2t out, and I'm going to write down what's left. Divide it out of here, I'm left with 5s. Divided out of here, I'm left with minus 2t, which is exactly what I had up there. Granted, up here, the 5s minus 2t is in the front. Here it's in the back. But remember, having the parentheses, 2 times 3 is the same thing as 3 times 2. So I can reverse my parentheses, and it's completely the same. Now, box method, remember, starts the same way factoring by grouping does. I'm going to take my 15 and multiply it to my 4. And 15 times 4 is 60. So I want two numbers that will multiply for 60. They are going to add 4, this 16 that's here in the middle. And once again, that is a 10 and a 6. So I'm going to take my trinomial, my 15s squared. I'm going to split this up as a minus 10st minus 6st. And I'm going to keep my term in the back. So remember, box method starts the same way as factoring by grouping, but here's where we take our detour. Instead of putting those 4 terms and pairing them up, I'm going to put them inside of this box. So my 15s squared will go up here, and I'm going to snake my way around the box. My minus 10 st will go here. Let me make my box a little bit bigger. This is kind of hard to see. There we go. That's going to be a whole lot better. There. 15s squared. Snake my way around the box. The minus 10 st will go here. The minus 6 st will go here. And my 4t squared will go here. And then recall, I'm going to factor across the rows and up the columns. As I go across here, I can take a 5 and an s out of each. As I go across here, I can divide a 2 and a t out. As I go up here, both are divisible by 3s. And as I go up here, both are divisible by 2t. And once again, if I'm confused about whether or not I should take those negatives out, just remember that this tells me same signs, both minus, so I need a negative out of here and a negative out of here, giving me a 5s minus 2t, which is right here, and a 3s minus 2t, which is right here. And one more, slide, divide, and reduce. The name tells you exactly what to do. So I'm going to start off the same way that I started off with my factoring by grouping and the same way that I started off with the box method. I'm going to slide this to the back by multiplication. Here is the slide. When I slide it to the back, it creates a trinomial that is pretty easy to factor because I have a leading coefficient of 1 here. So I'm going to go ahead and factor it. Remembering this tells me same signs, both minus. The nice thing is there's only one way to split up an s squared. So this eliminates a lot of the guesswork we had to play up there and guess and check. Now, t squared only splits up as a t and a t. So I want two numbers that are going to multiply for 60. They're going to add for a 16 since these signs are the same. Here's those magic numbers of minus 10 and minus 6. Now, here comes the divide, because remember, what I multiplied out, it's not magic, it's math. So what I multiplied out, I got to bring back in, so keep everything all even. So I'll take that 15 that I divided out, that I multiplied out, I'll divide it in here, and I'll divide it in here. And remember that critical step of reducing, slide, divide, and reduce. Even though other YouTube videos will simply call it slide and divide, I'm trying really hard to call it slide, divide, and reduce because this is so important. 10 over 15 reduces or simplifies to 2/3. And 6 over 15 simplifies or reduces to 2/5. And so now, I'm going to look at this and I'm going to say, I don't have fractions in my answers, so to clear this out, I'm going to multiply everything by 3. 3 times s will be 3s, and when I multiply this by 3, I get in minus 2t. So 3s minus 2t is right here. And then on this one, to clear out the 5, I'll multiply both of these terms by 5. 5 times s is 5s. When I multiply by 5 here, it cancels, and I get a minus 2t. Here's the 5s minus 2t. And once again, this step of reducing is crazy important. Because right here, if I don't reduce, I'm going to get a 15s minus 10t. Here I'm going to get a 15s minus 6t. That's nowhere close to that. So this step of reducing is insanely important. Okay, let's try a couple more examples just because you guys know I like for us to feel comfortable. I like for us, nothing to shock us. And I like to have lots of practice so that we get very good at this. Enjoy that lovely West Virginia scenery behind me. And let me get all this out of here. The board still have a little bit of trouble erasing, but we're getting there. Okay, next example. We have an 80z to the third plus an 80z squared minus a 60z. Now recall, I've told you guys many times, always do what first? Exactly. Divide out that common monomial before you do anything else. Now, hopefully you're noticing this one. Oh, now hold on a second. Yes, there is something that I can divide out of every single term. I can divide a z out of every one of them, but look at the coefficients. 80, 80, and 60. I can definitely divide a 20 out of every one of them. So I'm going to divide that 20z out before I do anything else. When I divide this by 20z, I'm left with 4z squared. When I divide this by 20z, I'm left with 4z. And when I divide this by 20z, I'm left with minus 3. Now I'm going to look at this and I'm going to say, is there anything more that I can divide out just to make sure I'm not messing anything up? And there's not. So now I'm ready to head for that double parentheses. This is the point where we have these four methods. So let's take a look at that old guess and check. Can't even spell it right. Hold on a second. The old guess and check. And recall with the old guess and check, we just take some guesses. Now, right now, I'm kind of ignoring that 20z for now. I'm going to keep it because remember, I need to be able to get back to the beginning. But I'm just focusing on this part right now, this 4z squared plus 4z minus 3. I'm going to try to factor it. So with that old guess and check, I'm going to set up my double parentheses. Remember, the back sign here tells me I've got opposite signs. One's a plus, one's a minus. The nice thing is splitting this 3 into these two slots, there's only one way to do it, a 3 and a 1. Not that much guesswork going on here. But this 4z squared could split up as a 4z and a 1z, or it could split up as a 2z and a 2z. So I'll try the 4 and the 1 first, and if that doesn't work, I'll try the 2 and the 2. Remember, don't worry about first and last, just outer and inner. So out here I get a negative 4z. Inside I get a positive 3z. That gives me a negative 1z, which is not what I want. I want a 4z. Before I toss out the 4 and the 1, I'm going to switch it up. So let's call this the 1 and let's call this the 4. Now on the outside I get a minus 1z, and on the inside I get a 12z, and that gives me an 11z, which again is not what I want. So that means the 4 and the 1 is not the right combination. Let's try the 2 and the 2. So now on the outside I get a minus 2z, on the inside I get a 6z, which gives me a 4z, and I have exactly right number, right sign. This is the correct way to factor it. Now, I did something very bad. I circled this as my answer, but that's not my answer, because remember, if I FOIL this, it'll only get me to here. I need to get back to the very beginning. I'm kind of glad I made that mistake because it's a very important thing for you to understand. I need to get all the way back to the beginning. Foiling this only gets me to here. I need to keep that 20z in there so that when I FOIL this and get to here, then I distribute the 20z through. That gets me all the way to the beginning. So my answer is actually going to be, let's see, 2z plus 3. So I'll have a 20z times 2z plus 3 times a 2z minus 1. And that is the correct answer. Yes. Keeping that 20z in there. Now, let's take a look at factoring by grouping in case that was a little exhausting for you. Now, recall that all these four methods, they only are taking care of the trinomial that's in there. I've got to remember that's 20z. I can't lose it. So now with factoring by grouping, recall what's going to happen is I'm going to take that 4, I'm going to multiply it to that 3, or that negative 3, to get a negative 12. So I want two numbers that are going to multiply for negative 12. They are going to add up to be a 4. Or in other words, they're going to combine to be a 4. So multiply for negative 12 and add up for a negative 4 is going to be a negative 6 or positive 6 and a negative 2. Positive 6 and negative 2. So I'm going to split this in that method, or in that manner. 4z squared minus 3, I'm going to retain the first term and the back term. This gets split as a positive 6z minus 2z. Because these two will combine to be that 4z, and they will also multiply for the negative 2. And at this point, remember what I'm going to do with factoring by grouping is I'm going to pair these up, and I'm going to pair these up. With these, I'm going to say what's common that I can divide out. I can take a 2z out of each one of them. Divide this by 2z, and I'm left with 2z. Divide this by 2z, I'm left with 3. And then on this one, I can take a negative out of both of them. And when I take the negative out of that 2z, I'm left with 2z. Take the negative out of here, I'm left with 3. And here they are, those two funky looking terms. Both of them have that common parentheses. So I'm going to divide that common parentheses out, that 2z plus 3. I'm going to write down what's left. Take it out of here, I'm left with a 2z. Take it out of here, I'm left with minus 1. That is exact, I did it again. That's exactly what we have here, except Yet again, I forgot my 20z. Oh my goodness, this is horrible. I know better than that. There it is, because when I FOIL this, it'll get me to here, but then I need to distribute my 20z through to get me back to the beginning. So let's take a look at box method. Again, box method starts just like factoring by grouping. I'm going to take that 4 and multiply it to the -3 to get a -12. So I want two numbers that are going to multiply for -12. They're going to add up to be that 4 that's in the middle, because I want to split this into two terms. Yet again, that's that 6z minus 2z. So I'm going to split this 4z into a 6z minus 2z. And I'm going to retain that -3 in the back. But here's where we take that detour with our box method. With the box method, we're going to take these four terms and snake them around the box. The 4z squared goes here, and work my way around. The 6z goes here, the -2z goes here, and that -3 goes back here. I'm going to factor across and up the rows. When I go across this way, I can divide a 2z out. Go across this way, nothing but a 1, and I'm going to take that negative out with it. Going up here, I can factor out a 2z. And going up here, I can factor out a 3. Now remember, if I'm worried about the signs, whether to take those negatives out, clearly a negative will come out of here. But just remember that back here, this meant opposite signs. One's a minus, one's a plus. So I've got a 2z minus 1 that I see right here, and a 2z plus 3 that I see right here. And remember, I've got to keep that 20z in there like you see right here. Alright, so finally, slide, divide, and reduce. And once again, the name's going to tell me what to do. So I'm first going to slide by multiplication. So I'll take that 4z squared plus 4z minus 3, slide that 4 to the back by multiplication, just like we started factoring by grouping, just like we started box method, leaving me with z squared plus 4z minus 12. Nice thing is, this is easily factored because we have a coefficient of 1 here. So I'll split my z squared up as z and z. Back sign here tells me opposite signs. One's a plus, one's a minus. Two numbers that will multiply for 12. Subtract for 4 because the signs are different. Here's that 6 and that 2. So now, what I multiplied out, I got to divide it back in. So here comes that divide. Here comes the divide. So I'm going to take that 4 and divide it in here. I'm going to take that 4 and divide it in here. And here comes that crazy important step of reducing. So important to reduce. This reduces to 3/2. And this reduces to 1/2. And yet again, don't have fractions in there. Clear that out by multiplying by 2. I'll get a 2z plus 3, which you see right here. And multiply this by 2, and I get a 2z minus 1, which you see right here. So here's my 2z plus 3, here's my 2z minus 1. But remember, that only gets me to here. I need to retain that 20z so that I can get all the way back to the beginning. That leads me to the very same answer. So, hopefully what you're seeing, and we're going to do a couple more examples, is first, always look to see if there's something common you can divide out. Do that first. And then take that trinomial and do these other 4 methods or any other method that you've got. So let's continue practicing, just because, like I said, I want us to get really good at it. And what if there's extra variables in there? Will that make a mess of what's happening? So hold on. Get this cleaned up. Again, enjoy that West Virginia scenery that's just gorgeous. Okay. So here's example C, and we've got a 12a squared b minus a 34ab squared plus a 14b to the third. Okay, so once again, always look and see if there's something common you can divide out before you do anything else. Notice with a 12, a 34, and a 14, I do believe that I can take a 2 out of each one of those. And notice as well that I can take A's out of here and here, but not here. But but I can take a b out of every single one of them. So I'm going to take that 2b out of every single term. When I divide it out of here, I'm left with a 6a squared. When I divide it out of here, I'm left with a minus 17ab. And when I divide it out of here, I'm left with a 7b squared. So now, take a look at this and say, is there anything more I can divide out? I mean, did I do all that common monomial factoring that I should have done? And there's nothing common to divide out. So I'm ready to do any of these 4 methods to factor this piece right here. So with the old guess and check, let me do this. Let me go ahead and write down that 2b, because I have a very bad habit of forgetting that, don't I? There we go. Now I'm ready for my old guess and check. Back sign here tells me same, both minus. Now, there's only one way to split up that 7b squared. Certainly a b and a b. And I'll have a 7 and a 1. I'm just not sure where the 7 goes and the 1 goes, but we'll figure that out. Now my 6, I have a couple of options. I've got 6 and 1, or I've got 2 and 3. So just give it a shot. Now there's only one way to split up the a squared. That's an a and an a. So I'll try my 6a and my 1a and see what happens. Out here I get a minus 6a. In here I get a, 6ab. My apologies. Inside I get a minus 7ab. That gives me a negative 13ab. Not quite right. But before I toss out the 6 and the 1, I'm going to switch it up and I'm going to call this the 1 and this the 6. Now on the outside I get a minus AB, and on the inside I get a minus 42AB. Whoa, that gives me a minus 43AB. Most definitely not what I wanted. So I'm ready to toss out the 6 and the 1 and try the 2 and the 3. Now on the outside I get a minus 2AB, and on the inside a minus 21AB, giving me a minus 23AB. Still not quite right. So let's switch them up and call this the 3 and call this the 2. Once again, don't switch these and these. That'll get you back to the same spot. So now I have a minus 3AB and a minus 14AB. There's the minus 17 that I wanted. So I know that this is the correct way to factor it. And thankfully this time I kept that 2B in there. Because remember, if I FOIL this, that will only get me to here. I need to get back to the beginning, which means keep that 2B in there. Now, let's try factoring by grouping. Remember, factoring by grouping only works on this piece. But the way factoring by grouping works is I'm going to take my 6, I'm going to multiply it to that 7. 6 times 7 is 42. So I want two numbers that are going to multiply for 42. They are going to add for that 17 that's in the middle. Now, the two numbers that multiply for 42 and add for 17 are a 14 and a 3. Because 14 times 3 is 42, and 14 plus 3 is 17. Remember, my goal is take that middle term, split it into 2 terms. So I'll keep that 6a squared, but this minus 17ab turns into a negative 14ab minus 3ab. Because negative 14 times negative 3 is positive 42, and they do combine to be that negative 17. And keep that 7b squared in the back. Now, remember the point here, that's kind of scrunched up. Let me change that up a little bit better. 6a squared minus 14ab minus 3ab plus 7b squared. That looks better. So remember, what I'm doing here is I'm pairing up these and pairing up these, looking for what's common that I can take out of both. Here, I can certainly take out a 2a, and I'm left with a 3a minus 7b. And here I can take a b out. Now remember, I want this parentheses to be the same as that. The way I've got it written, I'm going to have a negative 3a there. I don't want a negative 3a, I want a positive 3a. So that tells me, hey, I better take a negative out with that b. And now when I take that negative b out of here, I'm left with a negative 7b. There's those two very funky looking terms. One right here and one right here. And you can see that within the 2 boxes I do have common parentheses. So I'm going to take that common parentheses out, that 3a minus 7b. And when I take it out of here, I'm left with a 2a. When I take it out of here, I'm left with a minus b. But don't forget the 2b that was sitting out front. I need that because without it, I will only get to here. I'll FOIL this to get to here. Distribute the 2b to get all the way back to the beginning. And you can see that these are in fact the same answer. Now that box method, again, starts the same way. I'm going to take that 6, I'm going to multiply it to that 7 to get a 42. So I want two numbers that are going to multiply for 42, and they are going to add to be that in the middle, that's 17. That's going to be my 14 and my 3. So that means that I'm going to turn my trinomial 6a squared, split this up as a negative 14ab minus a 3ab. And I'm going to keep my 7b and the b squared in the back. Now instead of splitting or pairing these up, I'm going to put them inside my box. And so my 6a squared will go here. My minus 14ab will go here. My minus 3ab will go here. And my 7b squared will go here. I will factor across and up. When I go across this way, I can divide a 2a out of both. When I go across this way, I can divide a b out of both. And then when I go up this way, I can divide a 3a out of both. And when I go up this way, I can divide a 7b out of both. And once again, if I'm confused about the signs, this tells me same signs, both minuses. Oh, I better drag a negative out with each one of these. So I have my 2a minus b, there we go. I have my 3a minus 7b, there we go. And don't forget the 2b that's sitting out front. And finally, that slide, divide, and reduce. Again, it only works for this trinomial. So I'm going to take my 6a squared minus 17ab plus 7b squared. I'm going to slide it out by multiplication. There's the slide. And when I do, it creates a trinomial with a leading coefficient of 1. Leading coefficient of 1 is pretty easy to factor. So I'll go ahead and split it into the double parentheses. This splits as an a and an a. Same signs, both minus. The only way to split up a 7b squared is a 7b and a b. And now what I slid out by multiplication, I'm going to bring back in by division. Here's the divide. Here comes the divide. So I'm going to take my 7 and divide it by that 6. I'm going to take my minus 1 and divide it by 6. Reducing is critically important. Now this one doesn't reduce, so I'm okay. But I'm going to, something happened here. Oh my goodness, that should be a 42. Oh, I'm horribly embarrassed because I want two numbers that will multiply for 42 and combine for a 17. Oh, this is horrible. Minus 14 minus 3. I so apologize. There we go. Now we'll reduce. So 14 over 6 reduces to a 7 thirds. And 3 over 6 reduces to 1/2. And clear out that fraction by multiplying both sides by 3. You get a 3a minus 7b right there. Multiply both of these terms by 2 and I get a 2a minus b right there. And then don't forget that 2b that you need to keep in order to get all the way back to the beginning. Okay. Last one. Let's try this. Let's finish strong. Get one more example in here so that we will be very, very good at this. Beautiful West Virginia scenery, isn't it? Just gorgeous. Okay, so our last example here is 6x squared y minus 2xy minus 60y. And once again, always look first to see if there's something common you can divide out before you do anything else. As I look at these, I'm definitely going to be able to divide a 2 out of every term. And I can divide an x out of these two, but not that one. But I can certainly divide a y out of every single term. So when I divide this by 2y, I'm left with 3x squared. When I divide this by 2y, I'm left with negative x. And when I divide this by 2y, I'm left with negative 30. So I'm going to look at this and I'm going to say, is there anything more that I can divide out? Definitely not. So I'm ready for that double parentheses. So the old guessing check. Keep that 2y sitting out there. I'm going to need it. And once again, this tells me different signs. One's a plus, one's a minus. Only one way to split that up, as a 3x and an x. Now my 30, I've got several ways to split that up. That could be a 30 and a 1. It could be a 15 and a 2. It could be a 6 and a 5. Whoa, lots of guesswork going to happen here. So let's get it started. So we'll try the 30 and the 1. On the outside I get a negative 3x. On the inside a positive 30x. That gives me a 27x. That's definitely not what I want. So switch it up before I toss it out, and this will be a little easier to switch. So I'll move this to be the 1 and this to be the 30. Now I'm going to get a negative 90x, and on the inside a positive 1x. That's a negative 89x, most definitely not what I want. So I know the 30 and the 1 are not good options. Let's try the 15 and the 2. So now on the outside I get a negative 6x, on the inside a positive 15x. That gives me a positive 9x, not quite what I want. Switch it up before I toss it out. There we go. Now I get a minus 45x out here and a positive 2x in here. That gives me a negative 43x. Still not what I want. So clearly the 15 and the 2 are not the options. Let's try the 6 and the 5. So now on the outside I get a minus 15x, on the inside a positive 6x, giving me a minus 9x. Nope. Alright, surely this is it. 5 out here, 6 in here, I get a minus 18, and I get a positive 5, giving me a minus 7, and I messed up somewhere. What are my choices? It's the 10. Oh my gosh. I forgot. Oh, there was another choice. 10 and 3. I completely forgot those options. You can tell I'm kind of tired with this. 10 and 3. Okay. Now I get a negative 9x and a positive 10x, giving me a positive 1x. Okay, I have right number, wrong sign. Remember, right number, wrong sign simply means switch the signs. So now on the outside, I'm going to get that positive 9x. On the inside, the negative 10x. That gives me the negative 1x that I wanted. There's the right answer. And once again, for those of you who are completely worn out by that guess and check, let's try factoring by grouping. Now remember, factoring by grouping only takes care of this. And don't forget, keep that 2y sitting out front there, because when I FOIL this, it only gets me to here. I need to distribute the 2y through there to get back to the beginning. So this factoring by grouping only factors this part. I'm going to take that 3 and I'm going to multiply it to that negative 30 in the back, creating a negative 90. So I want two numbers that are going to multiply for that negative 90, and they are going to add up to be this negative 1 in the end. Those two numbers are going to be a negative 10 and a positive 1, positive 9, negative 10, positive 9. Negative 10 times positive 9 is a negative 90. Negative 10 plus that positive 9 will give me a negative 1. So I'm going to take my trinomial, my 3x squared. I'm splitting up that term right there. It splits as a negative 10x plus a 9x. Because negative 10x plus 9x is negative 1x, so I'm not changing this trinomial. I'm changing the trinomial, but this value has the same value of that trinomial. I don't want to change the value, just what it looks like, because this look is easier to factor. That was a little exhausting. So I'm going to pair up these, and I'm going to pair up these. Now as I look at these, I'm saying what's common that I can divide out. I can take an x out of each one. When I do, I'm left with a 3x minus 10. And here what's common is a 3. And when I take that 3 out, I'm again left with a 3x minus 10. So there's those two funky looking terms, one right here and one right here. So I'm going to divide out what's common, that 3x minus 10. I'm going to write down what's left. Take a 3x minus 10 out of here, I'm left with an x. Take a 3x minus 10 out of here, I'm left with 3. But don't forget, this foiling will only give me to here. I need that 2y sitting out front so that I can get all the way back to the beginning. And now let's take a look at that box method. Once again, the box method starts just like that factoring by grouping. I'm going to take that 3 and multiply it to the negative 30 to give me a negative 90. So I want two numbers that are going to multiply for negative 90, and they're going to add up to be that negative 1. And once again, that's a negative 10 and a positive 9. So I'm splitting that again as a negative 10x plus 9x. But instead of pairing these up, I'm going to take them and I'm going to put them inside that box. So my 3x squared will go here. My negative 10x will go here. My 9x will go here. And my negative 30 will go down here. I'll factor across and factor up. Factoring across, I can take an x out of each of these. Factoring this way, I can take a 3 out of each of these. Factoring up this way, I can take a 3x out. And factoring up this way, I can take a 10 out. And once again, if I'm confused about the signs, this tells me different signs. So here, I can take a negative out of both of those. Here, I'll just keep it as a positive. So I have my 3x minus 10 here, my x plus 3 here, and I got to keep that 2y sitting out front so that I can get back to the beginning. And here, lastly, is that slide, divide, and reduce. So my 3x squared minus x minus 30, I will slide it out to start. That gives me x squared minus x minus 90. This factors easily because I've got a leading coefficient of 1, so it factors as x and x. Opposite signs because the back sign's a minus. Two numbers that will multiply for 90 and subtract for a 1. There again is that 10 and that 9. So we'll do a minus 10 here and a positive 9 here. So that outside I get a negative 10x, inside a positive 9x, giving me my negative x that I wanted. But now I've got to divide back in the 3 that I multiplied out. So I'll divide it in here, and I'll divide it in here. And yet again, I need to do that very important step of reducing. So 9 over 3 reduces to 3. This does not reduce, but I can certainly fix that fraction by multiplying both of these terms by 3. And then I'll get a 3x minus 10. There it is. My x plus 3 is right there, and I got to keep that 2y. So hopefully you're seeing that even though you might have some extra variables in there, even though we might need to divide out something common, it kicks back to the same thing that we've been saying all along. And that same thing is always, 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 always look first to do that common monomial factoring. After you do the common monomial factoring, then head for that double parentheses. You've got these 4 methods. There are others out there that you're welcome to use. You don't have to know all the methods. You pick the one that you like. Pick the one that makes the most sense to you and go with that method. I hope this helps and have a great day.